I'm going to introduce Phoenix materials testing and what we do and why we're involved in high temperature and environmental testing. So what we are is we are specialist testing partners. So we work with a lot of organisations and a lot of leading universities who are doing work in research and development on their products. It's important that people understand that high temperature and environmental testing is complicated, and when you're trying to get accurate results, you need to be aware of what the different factors are to consider and how to go about setting that up. So let's start with the simple question. What does high temperature mean? Well, that depends on who you are and what industry you're in. Once you know what temperature you're actually going to work at, the next question is how are you going to heat it? A lot of this isn't just heating it, it's controlling that and measuring the temperature that you're going to and how accurately you can do that. So again, no surprises, there are multiple options. You can use thermocouples. Everybody knows about thermocouples. They're tried, they're tested. You can easily get UCAS calibrations up to 1300 degrees C. Relatively simple electronics, and for the majority of them, they're not very expensive. So you've got pyrometry, they're brilliant, up to 3000 degrees C, great. You can use thermal cameras. The ones we use go up to about 1000 degrees centigrade. The thing that I've just talked about is the use of thermal cameras and pyrometers and their sensitivity to surface finish and surface condition. So the easiest way to prevent something oxidizing is to take the oxygen out of the question. So you might want to put an inert atmosphere in, or you might want to test under vacuum to basically eliminate those problems. Simple one is you're actually simulating surface conditions. What does an environment mean? So you can add in corrosive gases or inert gases, or you can take things out. You can test under vacuum. You can add in humidity, you can add in pressure, and you can add in oxygen, or combinations thereof combined with the elevated temperatures, and all of these will affect the behaviour of your material or your component. There are some key things that you should be thinking about when you decide that you want to test under service conditions. So what's your material and your geometry, heating and cooling rates and methods, and don't forget the cooling. Do you require a controlled environment? If so, why? Essentially, testing is all about data, regardless if it's routine testing or it's complicated testing. So the starting point for anybody is what data do you need and why are you testing in the first place? And then go and talk to somebody who can guide you on what the pros and cons are of the different factors and different opportunities.